Hello students, today we are going to discuss the topic that is lanthanoids. What are the properties of lanthanoids? Today we will discuss. You know that all elements are classified on the basis of their filling of electrons in the outermost subshell. So whole table is divided into 4 blocks: S, P and D and F blocks. These lanthanoids and actinoids both are F block elements. All are F block elements, and these are also called as inner transition elements. And what are the actual definition of lanthanoids? Like already you know what is the definition of transition elements. The elements which have partly filled n-1d subshell, that is called transition elements. But if you see what are the lanthanoids or actinoids, lanthanoids means the elements which have n-2, that is 4f. 4f subshell is partially filled or incomplete. For lanthanoids, 4f subshell is incomplete, and that's why it is called lanthanoids. It has a specific place that is containing 14 elements in the series, and these all lanthanoids and actinoids are called as F block elements and also called as inner transition elements. Because why they are inner transition elements? Because their inner shell n-2f and n-1d are incomplete. n-2f and n-1d subshells are incomplete. Okay, that's why these are called lanthanoids elements. And what are the 14 elements of lanthanoids? The name is like this: cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, then ytterbium, then lutetium. So these are the 14 elements of lanthanoids, and atom number starts from 58 to 71. As these elements starts from lanthanum, that's why these are called lanthanoids. It starts from lanthanum, that's why these are called lanthanoids. The series is called lanthanoids. What are the properties of lanthanoids? Let us discuss. First, we will discuss the electronic configuration. Electronic configuration. The general electronic configuration of lanthanoids is n-2f 1 to 14, then n-1d 0 to 2, then ns2. So this is the general configuration of lanthanoids. But generally it is 0 to better, it is 1 to 0 to 1. So n-2f 1 to 14, n-1d 0 to 1 and ns2. So this is the general outermost electronic configuration of lanthanoids. Here it shows the n-2f subshell is incomplete and n-1d cell also incomplete. That's why it is called inner transition elements. As again one cell is lower than transition elements, that's why this is called inner transition elements. And if you see these elements, if it contain F14s. If it contain N minus 2 F7, these N minus 2 7 or N minus 2 14, these elements are stable. For example, we can see that gadolinium and your ytterbium. If you see gadolinium and ytterbium, these contain gadolinium contain 4F7 and ytterbium. If you see ytterbium, this YB also contain 4F14. So like this, these are, we can say these are stable electrons, half filled or fully filled. That's why we can say these are stable configuration. So this is the general electronic configuration of transition elements. Then next one is atomic size. If you see the atomic size, generally it is observed from cerium to lutetium, decreasing size, decreasing of atomic size. Atomic size decreases from left to right. This decreasing atomic size is called lanthanide contraction. Lanthanide contraction. This is called lanthanide contraction. Decreasing of size from left to right is called lanthanide contraction. Okay, why the size decreases from left to right? This is due to pore shielding effect. Pore shielding effect of 4F subcell, 4F electrons. As it has 4F subcell, we know F subcell has pore shielding effect. Due to electron in 4F subcell, and from left to right the nuclear charge is increasing but the shielding effect decreasing. That's why your size from left to right is decreasing. That's why it is called lanthanide contraction. This takes place in case of lanthanides. Then atomic size, if you see, if diagrammatically if you see, it will be just like this. If you see the diagram, this is your Z value and this is your R. If you see in case of lanthanides, that's the graph will be like this. That means decreasing atomic size, but the difference of atomic size, is very less difference of size. Difference of size is very less. If you compare the atomic size of the elements in the series, the difference of atomic size is less, but the size is decreasing from left to right. This is called lanthanide contraction. What is the cause of lanthanide contraction? Due to pore shielding effect of F electron, 4F electron. Then another important property of this is they produce color. Color compound. They produce color compound. Like your transition elements, they are also color. What is the cause of forming the color? Why they are producing color? Due to that F transition. Due to FF transition. Due to F of transition having unpaired electrons, Due to having unpaired electrons, and due to F of transition, they produce color. Another important property of lanthanides are variable valency, and oxidation state. Both variable valency and oxidation state, both they shows. What is the cause of variable valency? Having unpaired electrons, and vacant orbitals. Here vacant orbitals are F and D, both are vacant orbitals and unpaired electrons. But it is observed that it shows mainly +2 and +3 and +4. This type of oxidation state it shows. It shows this type of oxidation states, that +2, +3 and +4 oxidation state. Why they do not show more higher oxidation state? Because due to the pore shielding effect of F subshell. Due to pore shielding effect of F subshell, the outermost electrons are more tightly bonded by the nucleus. That's why the covalence is less. Already you have read, if the outermost electron is tightly held, that's why the outermost electron has less tendency to participate due to 4f electrons, which has pore shielding effect. So the outermost electron is tightly held by the nucleus. That's why the oxidation states are very low. That is less oxidation states, +2, +3 and +4. But +3 is highly stable. This one is highly stable in aqueous medium. Stable. +3 is more stable compared to +2 and +4. Due to this stable of +3 state, generally what happens that +2 state acts as better reducing agent. +2 state acts as, for example, samarium +2, europium +2. If you see, these are better reducing agent. Similarly, if you say that +4 state acts as better oxidizing agent. What are the oxidizing? For example, cerium +4, then we can say plasmodium +4. These acts as better oxidizing because it can reduce to +3 state. But +2 state can be oxidized, so acts as a reducing agent, and +4 state acts as reducing oxidizing agent because it can be reduced. So these are very important, that oxidation states and the stability and the nature of oxidizing nature and reducing nature. Then they produce complex. Important point is they produce complex. Like your transition elements, they also produce complex. Different types of complex also available of lanthanides, but the tendency to form complex compared to transition element is less. But if you compare the nature, the formation of complex in compared to transition element, it is low nature. Then another thing is acts as catalyst. We know the nature of a catalyst due to large surface area and variable valency, and the catalyst of this catalyst nature of almost all all lanthanoids shows catalytic property due to vacant subcell, that is D and F, and also large surface area. That's why it acts as catalyst. Another important property is produce alloys. Produce alloys. They are produce alloys. What are the alloys? And these alloys of lanthanides are called mixed metal. This is called mixed metal. MISH, mixed metal. This is called alloys and is used as pyrophoric alloys. Pyrophoric alloys. It gives heat, a light when it will be on that undergo pressure, and it produces heat or light due to pressure. Pyrophoric alloys, mixed metals. Then another important properties of lanthanides that it has high ionization energy. This ionization energy, if you compare, high ionization energy compared to S block. But if you see the comparison that your S block is less than your F block and less than your D block. Compared to your D block, it has low ionization energy. F block. That's why it is more reactive than D block. And due to this reactivity, it produces carbides. It reacts with oxygen, carbon, nitrogen, phosphorus, like this. Due to its high reactivity, it reacts with oxygen, produce oxides, with carbon, produce carbide, with nitrogen, nitrites, and with water also, reactivity with water, it reacts. Due to high reactivity, compared to transition elements, they produce different compounds with elements like oxygen, carbon, nitrogen, hydrogen. It produces hydrides, nitrides, carbides, and with water also produce a hydrogen gas and reacts with acid. With acid, it reacts. So reactivity is more than D block due to low ionization energy and that low reduction potential. Its reduction potential is low compared to D block. As a low reduction potential, it acts as what? More reactive compared to D block elements. So these are some important properties. High ionization energy, because these are DF block compared to S block, it is high ionization energy, produce alloys, acts as catalyst, and produce complex like your transition elements, and shows variable valency and some +2 state better oxidizing agent and reducing, and +4 acts as a oxidizing agent, +2 state reducing agent, like this. But generally, if you see, these lanthanoids produce oxides, the oxides and hydroxides. If you see, oxides and hydroxide formula is Ln2O3 and LnOH3. This type of oxides and hydroxide produced by the lanthanoids. Because the +3 state is more stable, so their oxides and hydroxide is like this. Then very important thing now we will discuss that regarding the lanthanide contraction. What is the cause of lanthanide contraction? Due to pore shielding effect of F subshell, the outermost electron is strongly attracted toward the nucleus. That's why the size decreases along the series. This is the lanthanide contraction. What are the consequence? What is the effect? Effect of lanthanide contraction. What are the effects? What is the consequence of lanthanide contraction? This thing we will discuss. Effect of lanthanide contraction. First effect is very important. Is first one is that decrease of basic nature of oxides and hydroxides. That means from left to right, the basic character of oxides and hydroxide decreases. Because size decreases, that's why we know basic character depends upon the size. If larger metals, more basic. As the size decreases, already see the graph, if size decreases, then basic character of oxide and hydroxide decreases. Then another thing, due to this lanthanide contraction, already you have discussed that 4D is approximately 5D as per the size. That means the 4D series and 5D series, their size approximately same due to lanthanide contraction. Due to lanthanide contraction, the first example, zirconium, hafnium. Zirconium is equal to hafnium. If you compare the size, zirconium is equal to hafnium due to lanthanide contraction. Another very important is difficult to separate. This is one, because their size is decreasing from left to right, but the difference of size is very less. That's why it will be difficult to separate. It will be difficult to isolate the lanthanides from the mixture due to very less difference of atomic size. So these are the very important properties of lanthanides, and almost all lanthanides are used as different. Mainly they are used as alloys. Lanthanides used as alloys, and they are alloys called as mixed metals, used for preparing bullet and shell, lighter flint, bullet shell, lighter flint. That alloys of lanthanides called mixed metal. Alloys of lanthanides is called mixed metal. It's a mixed metal. It uses pyrophoric alloys, so it uses bullet shell and also that lighter flints. So these are very important properties of lanthanoids. And if you compare the properties of lanthanoids and transition elements, lanthanoids, remember, are more reactive than already written, more reactive than D block elements, because it has low reduction potential compared to D block elements. And due to the low reduction potential, it reacts with acids, reacts with oxygen, carbon, nitrogen, phosphorus, hydrogen, like this, produce carbide, nitride, oxides, hydrides, and with water produce hydrogen gas, with acid also produce hydrogen gas. So it is more reactive compared to transition elements. So these are the important properties of lanthanides. Okay, thank you.